And we'll get to that when we do about the final exam stuff. That'll be Wednesday. So if you look at my calendar real quick, and sorry, there's that. I did finish it off for the semester. This is ours, right? No, that's the wrong one. Whoa, that's for fourth quarter last year. There it is. So I did finish it off up till the finals. Made finals real big there, and made stats quiz real big. Really, it should be Wednesday because we're done here. Monday's the last day, and I hope you really find today's easy. It really is not that bad, and really hope that people that need the points, you really get going here, all right, and do work, all right, and actually get this easy chapter dominated so that your grade can raise. And if you turn in some homework assignments, you'll be amazed, like these 4 or 5 homework assignments for those that have not been turning in, how much that might change your grade. I have to say this in an honors class, YouTube. That's where we're at right now. But there's only a handful that are not doing that, and hopefully you make some changes. Okay, go to the sheet. I'm going to make a comparison. This is why the setup is a little bit longer than you may very well. I may leave you like 10, 15 minutes, and that might be enough to finish your homework today. It really is not a big deal, this stuff. All right. But there might be some more cloudiness. Wait, what the heck just happened yesterday? Like, what was this thing, this curves, and all of a sudden I got this bell curve and probabilities and all that other stuff. And I'm going to compare this to this today. And then I have a statement on our notes, and I do want you to write it down when I show you it. But the empirical rule, I told you, is just an estimate. It's an estimate of the probabilities that something like this is going to happen. So I'm going to use the height example. No one should get offended. That's just, we're speaking of human beings and let's say males. And let's say the average height is 5'10". I'm just grabbing a height. So what this means is at 5'10", that would be a standard deviation of 0. All right. And what that means is somebody that's 5'10" is taller than 50% of the population. You get it? Because that's right, it's right in there, and that's what that means. So then what's a standard deviation of 3 mean? I don't know, I just made up something like somebody that's maybe 7'10", which barely happens. So somebody that's 7'10" is taller than whatever 100% minus 0.15% is. So that's 99.85%. So somebody that's 7'10" would be taller than 99.85% of the population. This is what this means. Again, this is an estimate. Now what you have in front of you is, by the law of large numbers, if we collected a lot of data, all of the people in the world with heights, then these percentages are more precise. Well, let's look at the 5'10" person first and analyze this sheet. Right down here at the bottom, this is a z-score of 0. There's no such thing as -0. And then -0 point, let's look all the way up to the top here of this, 0, 0. See? So that is a z-score of 0.00. And notice what part of the population is below that. What percent is that, everybody? 3, 2, 1, go. 50. That coincides perfectly with the empirical rule. Okay, but now let's look at the empirical rule and show how it's a little bit off of this spreadsheet. I hate that this notes do this. It should stay right at the page where I was at. So I'm going to have to do this every single time I toggle between these 2 pages. All right, let's say a z-score of 1. So a z-score of 1, I don't know, what would that be? Somebody that's 6'3". I just make we're going to have questions like this Monday where we got real world numbers, then we got to convert them to z-scores, and then we'll make that connection. But that's what that means. Somebody with a standard deviation of 1 is taller than the mean. And they should be taller than 50 plus 34, which is 84% of the population. Just making up a number there. Well, let's look at what z-score of 1 is on our chart. Is it 84%? Well, here's a z-score of 1. You have to go to the other side, and that's how this reads. Your shading is not as great, but these probabilities that they list here for the z-scores is the probabilities left of the z-score. All right? So for 1, there we are. We're right here. And this is how you read the sheet. This is a z-score of 1. This program is the worst. All right, let me get this up here. I want my old program from 2013 for notes. Anyway, look at how barely it is off. It's supposed to be 84% from the empirical rule. It's actually 84.13%. So again, I'm toggling between the empirical rule and this sheet and showing you how this, this works out and why the empirical rule is considered an estimate. By the way, for the final exam, we stopped at the empirical rule. We didn't want to have like just 1 or 2 questions you having to use this sheet. You don't need this sheet for the final, okay? And we're just kind of introducing this idea, and it's really the backbone of statistics, using this and probabilities and all this other stuff. All right, one more maybe comparison between the two. Let's go to that 3 deviations to the right. And that was 99.85 using the empirical rule. All I did was 1 minus 0.15, or 100, sorry, minus, because this is in percents. So going back to the z-score chart, I got to go all the way down to 3.0. What did I say? 99.85? It's actually 99.87. That's 0.2 off. So that's really not that big of a deal. Okay, so again, comparing the two. But then here's the other problem, and now I'll show you the notes. The other problem is the empirical rule only works when you're spot on. 1 deviation, 2 deviations, 3 deviations. Not 1.1 deviation, 0.7, negative 3.2. So what happens if your decimal deviation's away? You need to use something different. You need to use the z-score chart. Okay? So again, the comparison between the two. We should be writing this down. I don't see anyone really doing that right now. So it is the beginning of the notes here. Stay 4. So, standard normal distribution. I didn't give you a note sheet because this is the longest thing you have to write. And then I'm going to have, a couple other things to realize. The empirical rule is okay if your x values are exactly 1, 2, or 3 deviations right or left of the mean. It is also a ballpark estimate of the probabilities of these whole number z-scores. That's actually incorrect. They're integers because there's negatives. So don't worry about that. That's a mathematical thing I did wrong there. And it's a quick and easy way of estimating. Stop right there. On the final, it's only empirical rule. All right. Again, we don't want you to have your sheets out for just 2 questions on the final. Now we must use our standard normal probability sheet to calculate probabilities for z-scores that are actually decimals. Okay, and then off to the right of this or below it, or I don't know how you're doing your notes, it doesn't really matter. Just remind yourself of the last 2 days of notes that we actually had notes, not counting the video day. Remember, this is what happens, z-scores. Remember this variable, this is mu. You can just consider that m for mean. I know there's 3 m's, but standard deviations are based off of the mean. Box and whiskers are based off of the median. There's 2 differences there. So mu stands for actually mean of a population. Again, we're not going to get into those semantics. If you take a stats class your senior year, they'll go through all that. Difference between populations and samples, and it is a big deal. I was talking with my last hour about, in the past, college algebra trig. You know how I talk about them. That's what I was talking about, the homework thing, and some of the students are still going through a disaster in my cat class. They just can't acquiesce. Their 2 years of habits are just stuck. And I actually talked to you about habits with Warren Buffett's article. I think I did. I know with my cat students I did. Some of them are just ingrained and it's stuck, and I think they're doomed, all right, because they're just not going to change. We're in December and they have Samuelus as a teacher and they can't stand it, this no homework thing. But, it's more so back in the day I had juniors in my cat class. And then they would take stats as a senior, and those students would dominate the stats class. Stats is way different. You add, subtract, multiply, and divide mostly. It's all formulas, and then it's knowing where to put the numbers in the formulas, and then there's some writing. So it's a way different math class. You got a hand up there? What's up? Can I do what? You should come up here and sit in the throne here, sit in my chair, all right? Get a better view. So anyway, stats. I'm not trying to sell it. I'm just saying it is an interesting class. Actually, very, very, very practical math class. Especially when I showed you 2 or 3 days ago, college majors that you'll end up having to take stats. And that one little document, it said 100 and some different majors or fields or something like that. You'll be surprised. It's always funny that I had when I taught that people that were doing a nursing program through here, and but like in conjunction with JJC, and they have to take stats, and probably surprised about that. So anyway, okay, moving on, and we must. Okay, a couple things maybe to write about this. Of course. And then just kind of like I'm going to toggle between this little statements here and then our z-score chart. So again, maybe I should use a different thing, but no one should be offended. Everyone has different heights. It doesn't really matter. So back to the height thing. Let's say 5'10" was the mean. Okay. Well, you get a z-score of negative 3.49 if you were like 3'10". I mean, I'm just being honest. All right, you're going to be shorter than almost everybody. All right, that is why the cumulative area is close to zero. There is almost 0% people that are shorter than somebody that's 3'10". Right? I mean, that's a very simple thing to think about. So that's why someone that's 3'10" would convert to a z-score of negative 3.49. But what I'm trying to get you to understand is, what does that zero mean? And that's what it means. You are taller than 0% almost of the people, because that's pretty short. Okay, so, and I'm going to go to the z-score chart real quick and show you that. Okay, so here we go. And this is how you read it, and I guess we should cover that. How you read this chart is this. This is negative 3.49. That's where this probability is right there. Okay, so this is what this means for the 3'10" person. I just made up a number. Again, don't think I'm coming up with these numbers scientifically. But you are taller than 0.02% of the people, right? Okay, that's what that means. That's what those numbers mean. And that's how you read this chart. This is the 100th position of the z-score, right? And then you move accordingly. Right. So again, functioning on this thing. I just noticed that regular math tours are exactly doing this right now. I love that I'm a tutor, because then I get to know what other classes are doing, and randomly get these people popping in from the different classes. So I also forgot to show you this, or maybe I did. The day that I introduced you the sigma sign, lo and behold, the Math 3 honors girl comes in, and they're doing sigma signs. They're doing summations. So it's actually a year from 3 or 4 days ago when I showed you that sigma sign. You're going to be dealing with those. Kind of neat that happens at that point. All right, we should know that as the z-score increases, so does the cumulative area. understand that as the z-score increases, the heights increase. If I was doing a height example, all right. And as you get taller, you're taller than more people, so that's why the percents increase. Cumulative area when z equals 0 is 50. That coincides with the empirical rule as well. And then the top dog cumulative area, this spreadsheet stops at 3.49. Okay, and then that's completely on the other side. 3.49 is all the way over here. 3.49, you can look up there. I'm not going to go there. So somebody that's, say a z-score is you're 8 feet tall. I don't know. I don't even know if that's a thing anymore. I don't know what the tallest person in the world is right now. But you are taller than 99.98% of the people. That's how this works. All right? And that's what I want you to understand, maybe in a real world context. Because that's what happens on Monday. Monday, all we do is it's not general z-scores, it's actually real world questions. And then all you got to do is convert them to z-scores and then do what we're doing today. So 2 easy days. Again, shouldn't be blowing this as far as getting our last couple points together. And yes, you should do the final review, and the final's 100 points. Okay. All right, so here's how this happens, and here's your first example. Okay, so really what I want you to do is sketch. So in all your homework questions plus the test, I'm asking for a sketch. Do you understand where we're at here, relatively speaking? Okay, so sketch the z-score, shade the area that they're asking, and then go to your table. No more empirical rule. By the way, you should understand how the empirical rule does not work. You can't. What do you mean 1.79 is a z-score? I needed 1, 2, or 3. I needed it right on the dot. I can't even evaluate that using the empirical rule. Doesn't make any sense. I don't know if I told you this. Sometimes I forget. On the final exam, it stops at the empirical rule. All right, we're going to make it nice and perfect. I do ask you to find a z-score. That's a different formula. But then all the questions deal with the empirical rule as opposed to these spreadsheet values. Because we didn't want you to have to use this sheet for just 1 or 2 final exam questions. So just really get that empirical rule, those percentages down, and you should be good to go. Okay, so here we go. Find the area left of. This is just the functionality of the sheet. Can you do it? So z-score chart, boom. What was that, 1.79? Is that right? Correct? Okay, so we got to go on the positive side. And again, understanding this. Here's the mean right in the middle. So on the positive side, you're dealing with z-scores that are bigger than the mean. So this is what this is giving you. That's what this is saying. So 1.79. I go down to 1.7, and then this is going to be kind of messy. I should use my pen. I was trying to use my mouse. 1.79, and I'm going to go like this one more time. This is how you read the sheet. You cross-reference these two. I'm going to hide this. So it's this percentage right there. All right, 0.9633. But let me go back to the notes, which will probably get floated back down to the top. No, it worked. Here's the graph of this. I don't know. I'm not going to grade you on this, but here's the average. And 1.79 is approximately over here. And this is what you're getting. What is this probability? Right there. Well, that is exactly what this gave me. So that is the answer. The probability is, what was it, 0.9633, or am I wrong? Okay, I can't believe I remember that. I'm having a hard time remembering, as I look from one sheet to the next. And that's it. Because that's what the sheet gives me. That's what the sheet gives me directly. Move on. Okay? Now it gets different. Find the area right of a z-score. All right? And I'll tell you what this means in context of the height question so that Monday goes smoothly. Monday is really easy. All right? Right of 2.03. Compared to the last one, 2.03 is a little bit farther right. But what I need is this. That's what I need. So this is like asking the question, let's pretend 2.03 deviations to the right of the height question, which was 5'10". Hopefully this coincides with things that I said before. But let's say this is someone that's like 6'9". All right. This is actually asking what percent of the people are taller than 6.9 or 6'9". That's not a lot of people, all right? But that's what I want you to understand in context of a real world question. What do you have to do to answer this question? Go to 2.03, which is right here. Again, one more time. And you don't want to mark up your sheet. You're only getting one of these. So if you are marking this up like I am, you just use your eyeballs. I'm trying to just get your eyeballs to do the right thing here. Well, you're going to use this sheet about 20 times. So you don't want to be marking it 20 times. 0.9788. So what's 0.9788? It's this. That's what this is. Somebody that's 6'8", I believe I said, is taller than 97.88% of the people. What do I mathematically have to do to find the blue? What's this all add up to, everybody? Hundreds. What do I have to do? Subtract. And it's 1 minus. Can someone tell me what 1 minus 0.9788 is? All right. And then that is what the blue is. I think I could kind of guess 0.0212. Did anyone type it on their calculator? This is the help that I get. 0.0212. All right. So if you're 6'8", only 2.12% of the people are taller than you. That's how that would read. That's how you convert that or translate that. All right. Anyway, between. Okay, so graphing this is approximately, 2.16. I think I just had so it's a little bit bigger than the other one. And then here's mu, the average. And then 0.93 negative, it's somewhere right around here. Not going to grade you, not going to get a ruler out. Just in relation to where the median is. The mean. That was incorrect, mean. That's what we have here. So here's what we're finding. We need to find this area. Okay? And then I'm going to use my pen. I'm going to use red for the first one. And actually, it should be pretty easy what we have to do for this. And help me out on memorizing this here. Or not memorizing, remembering. So here's negative 0.9 down at the bottom. Almost can see it. 3. One more time. Negative 0.9. I missed 3 right there. Okay, so it is 0.1762 or 17.62. So 0.1762. 0.1762. I have a person here. Oh no. I know that sheet. Okay. All right, grab those two. All right. So that is this area here. Is that what I want? Is that the final answer? Obviously, yes or no. No, that is not part of the area, but we're going to find out mathematically what we're going to have to do here. And I do want to put this as a probability. Sometimes people with decimals, they get confused. Z-score is how far you are from the mean. This is the probability that is left of that Z-score from looking up on your sheet. Then looking at this, 2.16, got to flip to the other side. 2.16. I did look at that correctly, right? Yeah, 2.16. 2.1 and then 1, 2, 3, 4, 5. I think it's this one from my previous one. Yeah. 0.9846. So I'm going to write that 0.9846. Hard to toggle between these two here. In blue, I'm going to show that that's what this is. And that was 0.9 what? What was the number? You got it right in front of you. Help me out. 0.9 what? 846. Is that the answer? Yes or no? No, and I should not have. This is why you graph it. This is not rocket science. This should not be hard to figure out. What do I need to do with these two if I just want this yellow? Here's this, and then I got to jump back this. So what do I do with these two probabilities? Subtract them. It ain't no rocket science thing. And of course, you're going to take bigger minus smaller. And this is why you should graph it. because then it makes it very simple what you have to do in order to find these probabilities. It really, really, really should. Okay, so that's why we demand the graphing of it so that you can get your answer. And you can go ahead and subtract. I'm not even going to bother you with the calculator and telling me what that is. All right, and then this last, a little bit annoying question. Notice my T got stuck over here. Find the area left of one score and right of another. So we should be able to figure this one out as well. But graphing this, negative 1.96, and I will graph that in yellow or red with yellow. So approximately right over there. You know, again, I'm not measuring this. Not saying, well, you should be a little bit more left. Nah. Right? And then 3.02, I'll put that in blue. And I'll actually put that in blue. 3.02 is way over here. But I want that. Okay, so then for the heights example, this is someone very tall. What percent of the people are taller? All right, very, very small percentage. Okay, so the first one, hopefully you get, is pretty straightforward. Negative 1.96. Got to go to this side of the sheet, and I'm actually more up here. Negative 1.96 using my eyeballs, go around to here. Oh, look at that. 0.0250 on the dot. Nice. 0.0, and then it just moved on me for the first time. Okay, so for negative 1.56 or 96, it's a probability of 0.0250, right? Did I get that right? So I do want that. Oh, by the way, what do I want to do with these two probabilities to answer the question? What do I want to do with these two? So I have this probability, and I want that with it together. So what do I do with these two? Add them. Okay, but how do I find a blue area? The way my sheet's constructed, I have to do what I did in the last question, which is subtract. So I'm going to write this in the proper way. Sure, we're going to add these, and I'll put this in blue, but how do I get that blue probability? Because of how the sheet is constructed, I have to do 1 minus what the sheet says. Because at 3.02, was it 3.02? Again, my brain, right? 3.02, yes. Here's 3.02's probability. What that means is if I'm that tall, I am taller than that percent of the population, which means what percent of the population is taller than me? The opposite of this, or the complement, which is 1 minus that. So 0.9987. Ah, did it again. 0.9. Nope, I hit the wrong one. Still did it again. So I got to scroll back down again. Love it, love it, love it. 1 minus 0.9987. Was that right? That is the true area of the blue. And then you press enter and get those probabilities. So you should, I mean, that's grade school. How do I get my final answer? Type it on your calculator. Okay, I'm done. Like I said on Monday, the only difference is real world questions, real world numbers. You convert them to z-scores, and then you do this. It's really true.